Hi everyone. So we are from group 7 and we're going to present question number 3 and question number 7. So for question number 3, let S is equal to xy in real number such that x squared plus y squared is equal to 100. So let's look at the first question, which is 3a. Determine the set of all values of x such that x is in S. So we are given the equation x squared plus y squared is equal to 100 from the question. So we just need to substitute the y value here into the equation given. So x squared plus 6 squared is equal to 100. So we just need to minus 6 squared both sides. And then we got x squared is equal to 64. And then we need to square root both sides. Then we got x is equal to plus minus square root 64, and we got x is equal to plus minus 8. So here we got x is equal to 8 or x is equal to negative 8. So for question B, determine the set of all values of x such that x9 is in S. So same like the first question, which is 3a, we just need to substitute the y value into the equation given. So x squared plus 9 squared is equal to 100, and then we got x is equal to plus minus square root 19. Hence, x is equal to square root 19 or x is equal to negative 19.
For question 3c, we need to determine the domain and range of the relation S. So from the equation, first we move the x squared to the right side and by y equals to plus minus square root 100 minus x squared. From this, we know that 100 minus x squared must be greater or equal to 0. And then we factor out this equation and we will got x. We will got x plus 10 times x minus 10. And then we do this table here to determine which one will get the negative value based on this equation. And the domain of relation S is from negative 10 to 10. For the range of relation S, we move the y squared to the right side and we will got x equal plus minus square root 100 minus y squared. And we will got this equation. We factor this out to get y plus 10 times y minus 10. And we do this table again and we choose the one that will got negative value. Hence, the range of relation S is negative 10 until 10. For question 3D, is the relation S a function from R to R? Explain. So, we need to determine whether the relation S is a function or not. We let x equals to 8 and substitute it in the equation, and then we will get y equals to plus minus 6. This means that the image of object A is not unique because we get two answers here. So, hence relation S is not a function.
So for question 7, determine whether the following functions are bijective or not. Give your reasons. So if you want to know that if a function is bijective, you need to find that the function is both injective and surjective, because it is said that a function is bijective if the function is both injective and surjective. So for question A, fx is equal to 2x plus 9. So we need to find whether the function is injective first by using the definition where fx1 is equal to fx2. So just substitute the function into both sides, and then we find that x1 is equal to x2. So hence the function is injective. So second, we need to find whether the function is surjective, where we need to prove that for all y in real number, there exists some x in real number such that fx is equal to y. So firstly, we need to let f is equal to y. So we just substitute the fx to y. So it will become like this. And then let x be the subject. So after we got the x, we need to substitute the x into the function like this. And then, as we all know that fx is equal to 2x plus 9. So just substitute the x into the function like this, and you will get y. So we get the fx is equal to y. Therefore, the function is surjective. Since both are injective and surjective, then the function is bijective. That's all. Thank you.
7b, fx equals to x squared where domain and codomain of the function is natural number. So fx1 equals to fx2, x1 square equals to x2 square, x1 equals to plus minus x square. Since the domain and codomain of this function is natural number, so x1 equals to x2. This function is injective function. Fx equals to x squared is not surjective. We can prove when we take fx equal to -1. Assume that the function f is surjective. Exists x natural number such that -1 equals to x2. Contradiction since x squared greater than equal for all x natural number. Assumption is wrong. F is not surjective. Since f is injective but not surjective, thus f is not bijective function.
Question 7. We need to determine whether the following functions are bijective or not. Give your reason. For 7c, fx equals to 2x minus modulus 2x, where the domain and range of the function are integers. Let fx1 equals to fx2, and we put the equation side by side and compare it. And at the end, we will get x1 equals to positive negative x2. Since x1 does not equals to x2, so f is not injective. For the proof, when we substitute the value of x equals to 1 or x equals to 2, we will get 0. Since different objects give the same answers means they have the same image, this means that they are not one-to-one function, so f is not injective. Hence, f is also not bijective.
For question 7, we need to determine whether the following function are bijective or not. For 7d, the question is fx equals to square root x minus 9, where where the f is a function from the real number to the real number. Then we need to let square root x1 minus 9 equals to square root x2 minus 9. And then we need to power of 2 to the both sides to remove the square root, and then we get x1 minus 9 equals to x2 minus 9. Then we remove 9 and we get x1 equals to x2. So the function is an injective. After that, we let x equals to negative 1 in element of real number. Then we substitute the negative 1 to the equation, and we get the square root negative 10. The square root function is only defined for non-negative real number. So the function is not surjective. Since the function is not surjective, then the function is not bijective.